Assalamu alaikum. I'm Hamza from Mechatronics Department of Air University. So this is Microcontroller and Embedded Systems lab. This is lab number 5. In this lab, we are going to interface the LCD and we will discuss how to interface the LCD, how to add its header file, and how to interface LCD with segment display and HEX Keypad. So this is LCD interface with microcontroller using C. This is the introduction to LCD. We can see that. So we can see that here, basically the introduction to LCD. LCD is used to interactive. LCD provide textual information from the microcontroller. It makes the applications in microcontrollers more come in various configurations, 16 cross 2, 16 cross 1. So we in this lab and in our lab we have used 16 cross 2 LCD. We have 16 columns and 2 rows. Then we have LCD control unit. LCD controller is responsible for all the operations within the LCD. So these are basically the pin configurations of this LCD. We have VSS, which is ground, then VDD, then VE, which is a contrast voltage, then register select, RW pin, read or write pin, then we have enable pin, then from D0 to D7 we have the data pins, then we have anode and cathode pins. On hardware we have A and K for these pins. So these are the pin configurations of LCD. Here we can see that VSS, ground, VCC, the main supply up to 5 volt. Then we have register select, read, write register. RWF0 we have write register, and RWF1 we have the read from register command. So from D0 to D7 pins we have the ASCII letters, ASCII codes for the letters and numbers that are sent to these data pins. Then we have communication modes. We have 2 communication modes in this LCD. These are 8-bit and 4-bit communication modes. LCD interfacing, function for 8-bit and 4-bit LCD. These are basically the registers, header files. So this is basically how to interface LCD. So our first task is just to display hello beautiful people on the LCD. Now let's come to the program. So we have performed this task in group, and this is the code in which first we describe the CPU speed using define command fcpu and 16 mega. Then we add the header file of AVR. We add the delay file, header file. In the in pane, we declare these ports, and this is the LCD function. And then we use a string in which we write hello beautiful people, which is to be displayed on the LCD. And then we have LCD left and right, which is to be 16, as we are using 16 rows to LCD. So this is the code about LCD. Here we does not discuss the header file, so we do not discuss here. Now let's open its Proteus. So in the task we have Proteus task. So this is the LCD from D0 to D7. These pins are connected to IO37, which is basically the port C, and RS, RW, and enable. So these read, write, and enable pins are connected to port B from IO53 to IO52. Then this VSS is connected to ground, as we first discussed that VSS pin is grounded, and then VDD pin is connected to the power, as we can see here, and then VEE pin through this 10K is connected to ground. Now we upload the hex file, as we have already studied that for any microcontroller to be work in Proteus, we have to upload its Proteus file. So we upload its Proteus file, hex file, sorry. So we uploaded its hex file. Hex file is uploaded. Now we will run this program and check what is going to be displayed on this LCD. So we can see that this hello beautiful. So this hello beautiful is displayed on this LCD. So we have seen this hello beautiful people is displayed on this LCD. So this is task 1. In task 2, we have to make a hex calculator, hex keypad calculator, and the result is to be displayed on the LCD. So first we see its hardware video. So we can see that we have patched the circuit on the breadboard, and these D0 to D7 pins are connected to port C, VSS to ground, and then the other pins to power supply. So, and enable read write pins are connected to port B. Then we uploaded the code, give 5 volt from the laptop to this Arduino, and when the code is uploaded, this hello beautiful people is displayed on this LCD. So we can see that this hello beautiful people is displayed on this LCD. So this was our task 1. Now coming to task 2. So this is the C file of this task 2, in which we make a calculator from a hex keypad, and the result is to be displayed on the LCD. This is the same code as we studied in lab number 4. Just we add LCD, its header file, and the result is then displayed on LCD. So we define the CPU speed, we add the header file of AVR, add the delay file, then man.h file for the calculator, and after that we use these functions, display function, display LCD function, so that the result will be displayed on the LCD, calculator function for the calculations, and pin to num function for rows and columns of hex keypad. Then we declare hex keypad numbers in hex. So after that we display num, use this display num, so that the hex of the numbers to be stored in this 14 display num14 array. Then we use this LCD num14 array, in which we stored our numbers and the operators. So then we have int main function, in which we define the rows, outputs, data pins, port A as output, port B as output, port C for the LCD, and port D for the relevance of LCD. This is LCD initialize function, which runs for 4 times from 0 to 3. And then we use this delay. So this is the function log column by log2 to convert the hex values into decimal. And then we store these values to num. And then this num is displayed on a 7 segment. This then stored in ret then stored in port B, and port B is displayed. Here we have the input check. If we have input check equal to, then variable 2 becomes num. If equals 3, variable 3 becomes num. And then we use the calculator function in which we store both variable 1, 2, and 3, so all these variables. So this is LCD display function, which checks if it is 0 cross 0 A. If our operator is 0 cross 0 A, then it divides the two variables and stored in the result, and then this scope is displayed on the LCD. If it is 0 cross 0 B, then it multiplies both the numbers and the result is stored in op, and op is displayed on this LCD. Same for other subtraction and addition operators. So display LCD variable 2. Whatever the result is stored in variable 2, and then we display this result. So this is all about this program. Now let's come to its Proteus. We just have to display it on Proteus. We do not have to make its hardware. So this is the Proteus in which we connected the rows to port A from IO22 to IO25, the columns of this HEX Keypad to port C from IO37, from IO34 to IO37. The 7 segment display then connected to port B, and from D0 to D7 we have connected from IO21 the port D, VSS to ground, VDD to power. So let's check by uploading the hex file of this code, whether this code runs or there are any issues in this code. So here we have the hex file of this code. We have uploaded it. Now let's check. So first we pressed 2. 2 is stored in it. Then we pressed 3. 3 is stored in it. Then we select the operator addition. So we select the operator, we select both operands first. So we again upload 2, then we select the operator addition, then we select the other operand 3, so 2 plus 3. So we can see that 2 plus 3, 5, 5 is displayed on this 7 segment display, and 2 plus 3 is equal to 5. The result is displayed on this LCD. So in lab 5 we have two tasks for LCD interface. First we just display hello world on this LCD, hello beautiful people on this LCD. Then we make a hex keypad calculator, and the result is to be displayed on this LCD. So these are two tasks. We perform both the tasks. This was all about lab number 5. For any query, you can comment below. Thank you. Allah Hafiz.